When selling high-consideration items like furniture or complex machinery on a standard Magento storefront, you run into a hard limit on what a standard product page can achieve. Buyers are forced to look at a two-dimensional image and mentally interpolate the physical traits of a three-dimensional object. This creates an imagination gap. Flat photography cannot effectively resolve questions about physical scale, how an item fits into a specific spatial footprint, or how light reacts to a specific material finish. Asking a buyer to guess these variables introduces a heavy cognitive load. That mental friction directly translates into hesitation, stalling the checkout process and extending the conversion cycle. The hesitation radiates out into the business, driving up cart abandonment rates and forcing customers to rely heavily on support teams just to answer basic questions about fit and dimension. The problem with these standard product pages isn't a lack of written information. It is the failure to provide the definitive visual certainty a customer requires to finalize a high-stakes purchase. The solution begins by replacing passive image viewing with interactive 3D visualization, giving the user active control to rotate, zoom, and inspect a digital model from any angle. WebAR then takes that digital model and projects it as a high-fidelity, three-dimensional object directly into the buyer's physical space. Modern WebAR executes entirely through the native mobile browser, stripping away the friction of forcing a customer to download a standalone application just to view an item. This immediately replaces mental guesswork with empirical, real-world visual proof. The buyer no longer has to imagine if an object works in their room. They can see exactly how it sits there. For Magento merchants, the core challenge is integrating these spatial technologies into the storefront without bloating page load times or degrading the existing user experience. Deploying WebAR is a structural shift in how digital storefronts replicate the physical evaluation process online. 3D models provide an incredibly dense layer of visual data, allowing users to zoom in close enough to inspect hardware hinges, fabric textures, and precise structural details. To bring these models into the real world, the browser leverages underlying mobile frameworks, specifically AR Core for Android and ARKit for iOS, which enable native spatial computing. The phone's camera detects flat surfaces, projecting an expanding grid matrix. Once established, the 3D object drops into place. Anchored to these planes, the product renders at a strict one-to-one physical scale, proving exact dimensional accuracy. A buyer evaluating a sofa can physically walk around the projected model to verify spatial fit, ensuring it perfectly aligns with existing furniture. By answering these specific geometric questions instantly, you eliminate the primary reason a buyer delays an online purchase to visit a physical showroom. WebAR effectively neutralizes spatial uncertainty by allowing the buyer's actual living environment to serve as the fitting room. While the front-end viewer is the visible interface, a successful spatial commerce strategy relies entirely on a rigid back-end data architecture. This database schema maps standard alphanumeric SKUs to their corresponding 3D files. A single parent SKU branches into multiple child nodes for color variations, each linking strictly to a distinct GLB or USDZ file. If these product variables and 3D assets become misaligned in the database, a customer might select a walnut finish but see an oak model rendered in their room. That inaccuracy instantly breaks trust and kills the sale. Magento handles these complex product relationships natively, but developers must enforce strict naming conventions to ensure the exact correct file is called. Maintaining this strict, structured approach is mandatory. Without it, catalog scalability collapses the moment new product lines are introduced. Immersive e-commerce experiences appear highly visual, but at their core, they are complex data mapping challenges. For technical leadership, the immediate primary concern is that rendering heavy 3D assets will degrade page load speeds and penalize core web vitals. You mitigate this by utilizing highly optimized file formats. You serve GLTF or GLB files for web browsers and USDZF files for iOS devices, keeping payloads incredibly light. You then deploy aggressive caching strategies alongside global content delivery networks, ensuring these spatial assets load instantly, regardless of the user's location. On the front end, the View in Space AR activation button must be positioned intuitively, usually right alongside the primary image carousel.
The interface requires clear, simple controls for model rotation, paired with brief instructions guiding the user to scan their floor and establish tracking planes. These features must sit organically within the page, maintaining strict accessibility standards without pulling the user out of the standard checkout flow. Spatial assets must load instantly and operate seamlessly. Any added latency or user interface confusion destroys the purchase momentum you just built. You cannot evaluate the success of spatial features subjectively. Merchants must deploy a strict analytics framework to objectively track user engagement. You begin by capturing specific metrics, including direct interactions with the viewer, total model rotations, and exact WebAR launch rates. Next, you track the correlation between that spatial engagement and any subsequent increases in overall time on page. The analytics platform is then configured to map those specific spatial events directly to cart additions and ultimately final conversions. Post-implementation, you also track incoming support ticket volume regarding product size or fit, providing a secondary, verifiable metric for measuring increased buyer confidence. A user's interaction with a spatial model serves as a highly accurate, quantifiable predictor of purchase intent within a properly architected product page. Deploying 3D and WebAR yields stronger buyer confidence, directly reducing purchase hesitation at the point of sale. To address the logistical challenge of catalog scale, merchants should begin deployment strategically, focusing first on top-selling or highest-margin SKUs, where the conversion lift has the most impact. A heavy manufacturing CAD file passes through an optimization filter, emerging as a lightweight web asset that slots cleanly into the catalog grid. By enforcing predictable file naming conventions, the Magento backend automatically maps the resulting assets to the storefront. This automated mapping eliminates the bottleneck of manual data entry, enabling the rapid, simultaneous deployment of hundreds of spatial assets. Scaling spatial commerce requires shifting your focus away from individual asset creation and towards systematic operational discipline. Executing this architecture effectively requires specialized expertise sitting exactly at the intersection of 3D asset readiness and Magento backend engineering. Rave Digital provides a dedicated methodology designed specifically to support Magento and Adobe Commerce merchants through this complex architectural transition. They manage the holistic process from end to end, handling everything from strict product data alignment and performance tuning to conversion-focused user experience optimization. Evaluate your own digital storefront and ask yourself if your static product pages are actively causing buyer hesitation. If they are, reach out to Rave Digital for a Magento consultation and begin architecting a spatial commerce solution tailored to your catalog. Upgrading from static imagery to interactive spatial visualization is a definitive competitive advantage in modern digital commerce.